All right, guys, let's work some homework together. So assignments. So it looks like this tonight we have due our chapter 4 assignment. So let's take a look at it. Remember, you've got to click the book and click the video and watch it to get full questions for this, but it's just 5 short questions. So let's take a look here. All right, and so for our first question. Sugar is a major ingredient in many breakfast cereals. The histogram displays sugar content as a percentage of weight for 46 brands of cereal. The box plot compares sugar content for adult cereals and children's cereals. Complete parts A through C. What is the range of the sugar contents of these cereals? Let's look at this. Notice that if I pop this a little bit bigger, pop out, there we go. I can see that the percent sugar is ranging from 0 to 70. And in my box plot, I can again see that the sugar content is ranging from, okay, look, it looks like 1 up to 65. So I'm able to read it clearer from the box plots than I am from the histogram. And in fact, notice it doesn't seem like I have any cereals with sugar contents between about 30 and 35-ish, right? All right, so we're going to say from about, let's see, this is, that would be 5. Yeah, so it would be about, 2 right here, I see it, is the lowest value to 65 is the highest. So 65 minus 2, whoops, 65 minus 2 would be 63%. Describe the shape of the distribution. Notice that if I look at this histogram, I've got one big peak here, then a dip, and then another peak over here. That is bimodal. What aspect of breakfast cereals might account for this shape? Notice that if we look here, we see that a large grouping of the adult cereal is low in sugar, and then we have another peak for the children's. So it's the fact that the children seem to be 2 different categories, right? So cereals tend to either be very sugary or healthy low sugar cereals. And that would be right. Are all children's cereals higher in sugar than adult cereals? Look at this. Notice we have a gap here. The highest adult cereal has a lower sugar content than the lowest children's cereal. So yes, that is true. Which group of cereals varies more in sugar content? Okay, let's look at this again. Notice that adults are going from 2 to about 30. That's a range of 28 values in there. Children are going from about 35 to 65. That's about a range of 30 in there. So children's cereal tends to raise a little bit more. So let's see. Okay, let's check that. Is that true that the IQR is larger? Yep, the IQR is larger. So 28 versus 30, that's about equal. So I'm going to lean towards this statement, but let's check the others. Although the ranges appear to be comparable for both groups, the IQR is larger for children's cereal. That is incorrect. The large range of adult cereals, well, it's not larger than the children's, we know that. The larger range of children's cereals indicates that there's more variability in children's cereals. Well, it is larger, but only by about 2 points. So this seems like a more correct statement. Here are box plots of the points scored during the first 10 games of the seasons for both Alex and Iris, okay? Summarize the similarities and differences in performance so far. Notice our median values are pretty close to each other. but Iris has tighter, less variability. There's a wider variability in the scores for Alex. Both girls have the same approximate median and IQR. Well, they don't have the same IQR. But Alex has a larger IQR, that's true. So option D would be the most accurate. Choose the correct answer below. Okay, wait. The coach can only take one player to the state championship. Which one should she take? All right, so if we look at this, notice if I take Alex to the state championship, it's possible she may outperform Iris by a lot, right? But it's also true that she may underperform Iris by a lot. Iris tends to have more consistent point plays, even if they're not sometimes as high as Alex. So I would be inclined to take Iris because she's a more consistent player. Okay, so since we're going to the state championship, all right, I see. We don't necessarily want a consistent player. We want somebody who has the potential to score the highest. So we would want to take Alex because she has the ability, there's the potential that she could outperform Iris. Okay, so both A and D are, go back. Both A and B are possible. Yeah, notice those are both the two that we chose, depending on the coach's preference. That's true. I didn't even read down that far to see that that was a potential answer. But that would be the case. Do I want somebody who's consistently a better performer, or do I want somebody who may have a top-notch score? So it's up to me as the coach to decide that. 3 statistics classes all took the same test. Histograms of the scores for each class are shown below. Match the histograms to their respective box plots. All right, notice this one seems to be symmetric. If I look at the symmetry here, this is not a symmetric graph. So I know class 3 is not this one, right? So I'm choosing between class 3 as being this one or this one. Now, notice that if we look at the differences between these, our median value here is close to 60. The median value here, a little bit higher than that same value. But notice that the spread here of the middle 50% is much wider than it is here. Now, if I look at which one of these is kind of skewed, this one would be skewed to the right. So this class 1 is clearly the last graph because of the skewness. Now, once I know that, that means I'm deciding whether this one or this one matches this or this. Notice that the uniform distribution is more evenly spread out across the graph, whereas there's a concentration of values around the median in the symmetric one. So class 3 should be this graph, and class 2, the uniform graph. A survey of major universities asked what percentage of incoming freshmen usually graduate on time in 4 years. Okay, here's our summary statistics. Would you describe this as symmetric or skewed? Well, our mean and median are almost exactly the same value. That happens when it is symmetric. All right, notice that's said in A and B. We can rule out C. Now the difference here is that this says and the quartiles are approximately the same distance from the mean versus, and the extreme values are approximately the same distance from the fences. Well, if I look at my quartiles, they're about the same distance from our mean and our median, but our extreme values, the min and the max, are not necessarily the same distance from the fences. Because to get my fence, remember, I would take, let me show you here. I would take the third quartile, 76.86, minus the first quartile, 61.47. So I would get there. $15.39, and then we do that times 1.5. And that's what we add and subtract to those quartiles to get fences. So if I do the bottom fence, 61.47, and subtract 23.085, we get 38.385. And if I take 76.86 and add the 23.085, we get 99.945, right? So if I look at the distance from the mean, which is about 70 here, the mean and the median are both about 70, and I compare to these values, 70 up to here is about 29 places, and 70 down to there is about roughly the same, 30, 39 places, right? So we're relatively close, but it looks like that those quartiles are about the same distance from the mean. Oh, our extreme values are same distance. Okay, so our extreme values, 40 compared to 38 is, so this 40 is inside my fence. And the other one, 86, is inside this fence. But notice this fence is much farther away, right, than the closeness that's here to the 40. So 86 to 99 is a bigger degree. So we want to go with the quartile, the mean and median are reasonably close to one another, and the quartiles are approximately the same distance from the mean. Are there any outliers? No, both of these values fell inside those fences that we found. Now I'm checking the max and the min when I say that. I'm looking to see that the max and the min are inside these fence values that we found, and they are. A survey, oh, this is the same prompt. So where am I here? Create a box plot of the data. Okay, so we can rule this out immediately because there's not an outlier, so I know this is wrong. But our mean and median are both around 69, and it looks like that looks like they're all there. So we got that. Now we're going up to a maximum of 86, so it should be less than the 90, which would be correct here, but not here, because those both go to 100. And the lower whisker should go down to this min value, which is 40.14, which it does here, not to 0 and not below 40. So we want to choose option B as the box plot. Describe the graduation rate data. Universities surveyed had between our 25th quartile is 61.47. Oh, I'm sorry. The min and max is what we're going between, 40.14 and 86.78. Once we read the question, it makes more sense. Students graduating on time, with the middle 50% of universities reporting between, those would be the quartiles, 61.47 and 76.86. A student's study of the effects of caffeine asked volunteers to take a memory test 2 hours after drinking a soda. Okay. Some drink caffeine-free, some drink regular, and others drink a mixture of the two. The 5 number summaries for each group's scores are shown below. Describe the W's. Our who, okay, if we look at this, who is being asked to do whatever, it's asked, the volunteers were who was asked. What, they were asked to take a memory test. Where not specified. When not specified. How, memory test 2 hours after drinking the soda. Yeah, it was soda. And why? We want to see if caffeine affects memory. Name the variables and classify each as categorical or quantitative. So the 2 variables are the, okay, so if we look at this, our caffeine level is a variable, and then the test score, right? So oh, type of drink, there we go. Type of, some drink regular, caffeine-free, or a mixture of the 2. Now the other one is our test score. Now the type of drink is categorical, and the test score is quantitative. Create parallel box plots to describe the data. Okay. So now if I look at this, the no caffeine should have a median at 21, and then the low caffeine at 22, and the high caffeine at 19. (21, 22, 19). Okay, that works. So A could work. 21, 22, 19. Okay, that could work. That's below 20. So I can rule out this chart because it's supposed to be 21 for the no caffeine. And 21, 22, 19, that one could work. All right. So far, we have only ruled out. Now, that was the median. Now, if I look at my other differences, Q1 is 20 and Q3 is 24 here. So now notice that if I very quickly come over here and do 24 minus 20, I get 4. And 1.5 times 4 is 6. So 6 down from 20 would go to 14, and 6 up from 20 would go to 30. My max is inside there, and my min is inside there. So the no caffeine shouldn't have outliers. All right, now let's do the same thing for the other two, because we might, no, that rules out all of our outliers. So I don't need to check outliers on the other ones. All right, so now let's, because we're only now deciding between the first and the last graph. Let's take a look at the distance of between the median and between Q3 and the maximum. So Q3 to the maximum is 21 to 23 in the high caffeine group. So 21 to 23, if I look at this, high caffeine, here's 21. This is too high, that's not 23. So I can rule out this, which means that A is my only reasonable choice. Now, by the way, before I continue, here's the way that you'd make these box plots on your calculator. Actually, I would need the data, and this doesn't provide the, it might here. Let's see, open Excel. See if it gives me the data. Nope, it only gives me the summary statistics. So I would have to draw these by hand. I couldn't use my calculator to get them. Write a few sentences comparing the performance of the three groups. Okay, so we know we're looking at this chart. So notice that the no caffeine group potentially have the highest performance. The range is close to this group, the low caffeine group, but the low caffeine group's median is higher. And the high caffeine group has the lowest median and the potentially lowest performance by going down here. All right, so let's see if we can summarize that. The participants scored about the same with no caffeine and low caffeine. There we go. Right, because these two graphs, notice, are almost, they're close, right? Just a little potentially higher here. Medians are close. The medians for these two groups were one apart, 21 to 22, with slightly more variation in, notice, I have slightly more variation in the no caffeine group because things are more compact and tighter together over here. The the high caffeine group generally scored lower than the other two groups on all measures of the 5-number summary. And we can see that here, their high is lower, the median's lower, the low is lower. And we see that in the high group. Oh, what did we mess up? Let's see. Yeah. One apart, right? Because we're going from 22 to 21. Oh. So this Q1 to Q3 gave me more variation in here, same minimum value, a little bit higher on the maximum here. So there's a little more variation within this quartile here. So we can say a little more variation in the low caffeine group, looking at the variation here in the middle. The lows are the same, a little more variation here in the bottom part. Now this has higher variation on here, so that's a little bit misleading. And that's why I chose that one first. Okay, guys, that's our homework for this one. And so we'll stop this recording here. I might do the chapter 5 either later today or possibly on Sunday.